Merci, bonsoir, good evening everybody. It's a great pleasure to be here with you tonight. So what I will do tonight is just share with you some of the projects we do. Some of the projects we do in two places. One in the more research projects we do at Senseable City Lab, that's based in Boston, in Singapore. And then some of the more architecture projects we do in the design office that is started in Italy, in Turin, and now it's in Italy and UK and US. But I wanted to, and what I wanted to do was to show you some of the things the explorations we do, and I try to then relate them to adaptation. I know that adaptation is the theme of this year, that you're exploring this year. And what I will do at the end is try to show you how we see that actually the profession is changing, the way we practice architecture is changing, and how we need to adjust and adapt to new conditions. But before that, I just wanted to first tell you a little bit about our vision. Now, if you look at a field like Formula One, something interesting happened over the past 10-15 years. 10-15 years ago, if you wanted to win a Formula One race, you needed a good car and a good driver. Today, if you want to win a Formula One race, you still need a good car and a good driver, but you also need a system like this. A system that's made of thousands and thousands of sensors onto the car, collecting information in real time, sending that information to those computers where it's analyzed, it's processed, and decisions are made in real time. In other terms, that's what most engineers would call a real-time control system, which is a system made of two components: a sensing component, collecting information, and an actuating component, responding to that information. And sensing and actuating is really what every dynamic system does, or every living system does. When we see each other, when we meet each other, we sense each other, we look at each other, we collect information from each other, and then we respond to that information. So sensing and actuating is a key principle of life itself. Well, the amazing thing we believe today is that our cities are starting to behave a little bit like that Formula One racing car. Our cities have been covered, layered with many different types of digital information, and because of that, the way we collect information from our cities and the way we can respond to that information is changing. Almost as if every atom out there, the physical world, were becoming both a sensor and an actuator. Now, you might say, this is interesting, but where is all of this taking us? Where is all of this going? Well, there was an exhibition at MoMA, the Museum of Modern Art in New York, a couple of years ago. We were part of the exhibition. The title of the exhibition was Talk to Me. The idea that because of all of this sensing and actuating, it's almost as our cities, our buildings were starting to talk back to us. And if you look at architecture from the past, it has been a big struggle, the struggle to get something that's almost alive, that responds to us. And if you look at this is a beautiful Guarini building. If you look at this, trying to capture life and movement, and the same was true in the Baroque time, in many other times, and still today. This is Zaha's Bridge in Saragossa. But there's almost like a tragedy. If you look at all those buildings, they try to look alive, but they are dead. And that's the same tragedy that Michelangelo confronted when he sculpted the mosaic. So the story goes, when he sculpted the mosaic, he took a hammer, he threw the hammer at the mosaic. There's still a little chip on the knee, and shouted, "Perché non parli? Why don't you speak?" Well, today we believe, because of these new technologies, our buildings, our homes, our objects, our cities can speak back to us. And that's, I think it's like an old dream of architecture. Now, having said that, which is a little bit of what we try to do in terms of vision at the lab and in the office, I wanted to share with you some projects that are divided into two categories. One is about sensing, how we can collect information from our environment in a way that was not possible just a few years ago. And the other one, actuating, how we can respond to that information. Now, the first project I want to share with you is actually related to this computer on this table. If you take this computer today, you know everything about it. Every chip in this computer, you know where it was produced, how it moved on the planet, how it became this machine. However, when you stop using this computer a few years from now and you throw it away, you know very little about it. Sometimes this is what happens to it. A lot of electronics from Europe or the United States gets shipped illegally to where it shouldn't go, maybe to Africa or to Asia. You know very little. Today we know everything about the global supply chain, but we know very little about what you could call the global removal chain. What happens to things when we throw them away? So our idea was, what if we could actually design a little tag that we could put on trash and then follow trash? A little bit like what happens when you go to hospital, they put a tracer in your blood, and then they follow the blood through your body to see what works, what doesn't work. Could we do the same thing at the scale of a city? So we had to design the little tag like this one. We work with Qualcomm, a chip manufacturer in the United States, in order to engineer it. It's almost like a small miniature cell phone. And then we did the first deployment. We're still working on the project, but I'll show you now the first deployment we did in the city of Seattle. So 500 people and 3,000 pieces of trash, and we put a little tag on each of them. And after having tagged all of them, we started following them. The day of deployment, after a few days, some of the main landfills in Seattle. But then a big surprise how far things started to travel. Sometimes in crazy way. Look at some of those traces going east and then west for thousands and thousands of miles, and still moving after 1 month or 2 months. We thought that was the music we needed. So, what can you do when you got this information? That's information you couldn't collect just a few years ago. So what can you do? Well, the first thing, if you are an engineer, you take this information and look at all of these traces, and then you can try to optimize the movement. So you can say, can I design a more optimized system? And actually there's a lot of energy, for instance, that you can save, or money that you can make if you actually can streamline all those operations. The other thing we think is very important is that if you got this information, this incredible amount of data that we collect today, and here just as an aside, I want to tell you, if you take all the information produced by humanity from the beginning till 2003, that same amount of information is what you produce today every couple of days. So they give you a sense of this incredible amount of information we produce today, mostly in our cities, in the places we live. Then if you share it with people, then people can change their behavior. One of the most interesting things was at the end of the project, somebody came to us and said, I used to drink water in plastic bottles every day and then throw them in the bin and forget about them. But now after the project, I can't forget about them anymore. I know they go just a few miles from home in a landfill, and because of that, I stopped drinking water in plastic bottles. So the idea that all this information, if shared with people, can actually promote behavioral change. So it can promote some form of actuation, as we were saying at the beginning. There's a third thing we discovered with this project that was actually unexpected. And that happened more recently when a burglar came to our lab at MIT and stole many things, including some of the tags that tell you where they go. And this is what happened. Well, this was just to show you, to share with you some of the things we can sense today. There are many other types of data. Some of the data that's very interesting is the data that we all produce every day. Every day when we go online, we update something on Facebook, on Twitter, and so on, or on Flickr. Flickr is a database where a lot of pictures actually go. Then we're actually creating some information that could tell us something about what is going on. For instance, at the lab, we were one of the first groups to actually look at the information from Flickr and try to understand how it can tell us something about our cities. So, what you see here, for instance, is the city of Florence, and you're looking at pictures from Flickr, so all the pictures that people from all over the world take and then upload on Flickr, so open, publicly available pictures, and you can look at them. And you see, for instance, tourists, and people could take picture where they go in Tuscany. You see some of the main cities here, and then you can see Florence is one of the hotspots, and you can zoom into Florence, and you can see where people go inside Florence, and then you can zoom all the way next to the Duomo and see what happens there. Now, this tells you just where people take pictures, but you can do something a bit more sophisticated. What you can do, you can, for every picture, you do a little script on the computer, going and looking at the header that tells you at what time the picture was taken. If you do that, then you can create trajectories, because you've got spaces, points in space, in time. So what you see here, for instance, is Italians and Americans as they move in Tuscany taking pictures. And now I got a question for you. Where are the Americans? To the left or to the right? You need to choose one of the two. So Americans to the left, raise your hand. Who thinks Americans are to the left? You need to choose one or the other. Americans to the left, okay. Americans to the right. Okay, well, most of you picked Americans to the left, and actually you're right. If you are Americans here are to the left, and it makes sense, because if you're American, you go to Tuscany maybe once in a lifetime, or you go to Tuscany once every 10 years. You will go to the main cities. So you see it's almost like an elephant's path. You go to Genoa, to Pisa, to Florence, to Siena, to Perugia. While if you're Italian and maybe you've been there many, many times, you might even be from Tuscany, then you will go and look at small little places. Look at the little beautiful island, it's called Isola d'Elba, where actually no Americans there, but at least on Flickr, but a lot of Italians going and moving there. So this can be applied to many other things, the same analysis. This is something that our students were very interested in. It is how can you find the best places for partying in Barcelona. And as you see all the pictures in real time taken in Barcelona, and you analyze the pictures and you see where's the best place to go. I think they even managed to get a scientific paper accepted looking at the correlation between Britons and parties that seems to be very high actually in the city. And then you can do other things. You can look at each of these pictures, and a big problem in Spain is drought. The country gets very, very dry during the summer, and there's a lot of ways to monitor this. If you go into forest and so on, people use a lot of sensors to monitor drought. Well, in this case, what we're doing, we've been just looking at the pictures taken and seeing how the pictures change color over the year. And then that becomes a way to monitor drought, a free way, just by looking at all the pictures that the people take. We call the project the world's eyes, los ojos del mundo in Spanish, as a way, almost this is like monitoring all what happens around ourselves by looking at all these pictures, all these eyes, all the eyes of everybody and the pictures that we all take. Well, these are just a couple of examples very quickly, but then you can imagine, and this can multiply to many other different levels. And if you do that, you can really create a platform to collect and sense what is happening in our cities at many different levels. This is what we're doing in Singapore. In this project, we're trying to imagine a living city where we know in real time all what is happening around yourself. And so there is real-time information shared with everybody, with all the citizens about, in this case, it was about telecommunications, and so where the people are, energy consumption, as you see here, and here you see energy consumption and temperature. When it gets too hot in Singapore, you turn on the air conditioner, so that's when you also increase consumption. how the city responds to special events like the Formula One racing that you just saw. How you can have many other type of real-time information like all the taxis or all the weather information as you see here. And how the city expands and shrinks during the day based on the people on the road network, how long it takes you to go from one part of the city to the other one, and how all these flows actually, local flows, intersect with the global flows. So what you see here is all the flights landing in Singapore and taking off from Singapore, all the containers into Singapore and out of Singapore, and how they all intersect. Well, so this were just some examples of sensing. There could be many, many more about how we can collect real-time information from our cities and how we can then use it and respond to it. And that's really the most important thing, the response. So sensing is good, but like in the Formula One racing, then the goal is actuation, how you can respond to all of this information. Now, we saw before that, like in the case of the computer or the trash track or following trash, some actuation can happen just by sharing the data. And that's really in many cases, making this information available can promote a change in behavior, which is a way to change the city. Change the behavior in the city and change the way the city works. That can happen across many dimensions. In this project, for instance, what we've been doing is look at travel time in Paris. That's a project we've been doing with SNCF, the French railway company. So if you look at travel time in Paris, and if you look at time needed to travel to every spot in the city from any point, in this case from Saint-Michel, then you get a map like this. If you go by bicycle, it will take you longer, or by metro, or by car. But imagine tomorrow there was another type of parameter you have to take into account, like CO2 emissions. And then if you were to look about the Paris by carbon footprint, CO2 emissions, then it will look more like this, if you go by bicycle, by metro, or by car. So the idea with the SNCF was, how could we actually quantify this and give this information to people in a very easy way so that they can perhaps make different decisions. And over a third of global CO2 emissions are generated by transportation, so if we can actually change something there, we can have a big impact on the global scale. But the question, there's a few apps and there's a few systems today that allow you at the end of the day to calculate your CO2 emissions. But usually that requires a lot of input. It requires a lot of effort. It requires the fact that you actually say, well, I've done that many miles by foot, that many miles by car, by plane, and then you get your total CO2 emission. So the question, how can you do this without any user input? And, most of us actually have a smartphone in our pocket, and the smartphone has a lot of sensors, can sense a lot of things. Has GPS, accelerometer, internet, map queries, microphone, and so on. So what if you could actually use this in order to see the mode of transportation and hence CO2 emissions of people? Well, it turns out that that is possible. So if you look at that, this is, for instance, how your iPhone or your smartphone, how it sees you when you're doing different things. So this is the accelerometer in your pocket that sees you when you're on a bus or when you're walking or when you're biking. If you had horseback riding, you'll be able to tell trotting or galloping. So all of the different frequencies that you actually are applying in the way you're moving, and that is collected by the phone. Actually, this is now with the next iOS. We did this work a couple of years ago, but with the next operating systems, there's actually an automated way to see mode of transportation based really on this information. So we started, but now it's becoming the standard, and there will be more and more apps using this information. And if you do this, then if you present it, you can actually get, at the end of the day, you can know how many calories you spent, where you've been, how you could move in a more optimized way, and also how much CO2 you have emitted. And if you want, you can use that information to perhaps change your decisions about how you want to behave tomorrow. This is where basically the data itself shared with people can actually promote some change. In other cases, you might want to do some data analytics. In this case, and that's a way again to change the city, to take this information, analyze it, and see how this can help us in planning the city differently or in providing new services. This is a project we're doing in New York, and what you see here is taxis. That's the airport in New York, and you see all the pickups and drop-offs at the airport in different colors in New York. And then you can ask your question: what if people could actually share a taxi? It was difficult a few years ago to share a taxi, but now it's becoming very, very simple. With a small app on your phone, you can easily do it and see who else is going from the airport to the city. So what if you could do that? And what would be the effects on the city? Here is the idea. So, it turns out then you can ask yourself and try to quantify it, and you ask yourself what would be the minimum number of taxis, and you can think about taxis or something more comfortable like limousines or minivans, whatever you want, in order to take everybody to their destination exactly at the same time as they need to be there, say plus or minus a few minutes. So say at the same time, but what would be the minimum number of taxis to satisfy the mobility requirements of New York City? And you analyze it mathematically, what it turns out is that actually you need less. If you could count the number of taxis in your city by more than by almost 50%, by more than 40%, and you will still get everybody to their destination in time. So the idea that this information we collect from our cities can be useful in order to design new systems that can perhaps run the city more efficiently. Now, we have so much information from the city, but we also have a lot of information from inside the car. And the car itself is becoming a system to sense what is going inside it. In this project, for instance, we looked at this information in order to understand the status of the driver.
The drive was incredibly stressful. It was the most stressful drive I've ever been on. Nevertheless, I think we have a lot of great content to measure road frustration, because I'm certainly frustrated. So a lot of information collected from the city. So the city is becoming more and more sensing and intelligent. The car is becoming, in the same way, is able to collect more and more information. And out of the intersection between these two trends,
will happen something of the things that will change most radically mobility over the next few years, which is self-driving cars. As you know, self-driving cars have been developed. Google has one, MIT has developed one, many other universities and companies have been developing self-driving cars. You can find them on the road today, so they actually are already a reality. And this is what you see, for instance, with a self-driving car. This is how the car scans in real time, in 3D, the system and the world around itself, and then how it makes a model of it in order to navigate. Now, when you go self-driving car, then everything changes. Everything changes because the distinction between public and private transportation, for instance, blurs. The car can give you a lift in the morning to go to work, and then can give a lift to somebody else in your family or anybody else. So it's like public transportation. Or, you could think about a city where there's no traffic lights anymore. A city where, the crossings, actually in the crossings, cars mix in a magic way without bumping into each other, but without the need of stopping there. Something like this. Don't try to do it today, but it's a bit like Italy. But you can do this, and then it becomes a different way of really running the city. And that is actually one of the most interesting things that is already on the road and will happen over the next few years. Now, this is about mobility and how mobility can become autonomous, but there's that on the road, but there's actually other systems. A few weeks ago, we did a project at MIT. It was the beginning of the semester. And at the beginning of the semester, a lot of new people come to campus. And the MIT campus is very difficult to navigate. You've got plenty of buildings with different, every room has a different number. If you're not familiar, it's easy to get lost, especially for Harvard students. So this is what we did to help them.
Welcome to MIT. Where would you like to go? Follow me, please.
So all of this, I want to share with you in terms of sensing and actuating, which is really about how we interface with our environment. But what I want to do now is also to share with you some projects that are, in the end we are here at the Maison de l'Architecture. I want to share with you some projects that are more into architecture in a traditional sense. I believe that architecture is also all what we've seen so far. I think that architecture is really about designing the interface between us and the outside environment. Its architecture is something that's really deeply ingrained with us. It's something that goes back to our genetic needs and to what a beaver does in order to modify the environment around ourselves. So all these ways about learning about the environment, collecting information, and changing the environment in different ways just by sharing the information are, I believe, part of architecture. But at the same time, this is probably also going to change built architecture in a very interesting way. I would say that, Le Corbusier, almost 100 years ago, was saying that machine civilization is looking for and needs to find its architectural expression. La civilisation machiniste cherche et trouvera son expression architecturale. Well, today probably you could say the same thing, but it's not about machine civilization. It's about something else. It's a civilization, it's about digital, it's about biological, it's about nanotech and so on, and is looking to find a new way to design this interface between us and what is out there. So I want to share with you some experiments that we've been doing in this space. In this project, for instance, this was one of the first ones we did. We started from a very simple idea. There's a new type of projector, as you see here, which is what you see here, that from one position can allow you to project everywhere you want around ourselves. It is like, a standard projector, like the one you have down there, but you got a mirror in front of it, and this mirror is a little bit like what you have in clubs for dancing, in dance club. So it rotates, and actually then you got keystoning, automated keystoning, so that actually you can, the image can be corrected, is not distorted, and so from one position you can project a bit everywhere you want around yourself. So our idea was actually how could we design a space around it? And so basically the space, the geometry we developed was something we wanted to be beautiful, of course, when the projector is off, but also something where every surface, like here, could become a projection surface. And here you see the building, you see it's very simple. This was for a client in Italy who wanted to refurbish this space, which has very beautiful views to the mountains and so on. So the space is, I wanted to make it very, very, very clean. But the geometry was not necessarily done just because we like it, but because we were trying to maximize the co-visibility of all the surfaces. So that from one point you could actually have projections all around yourself. So here you see the building when the projector is off, so just as a very pure, simple project, or from the other side. But then when you turn on the projector, the whole space becomes animated, it becomes almost alive, as we were saying before. Another project we presented this year at the Salone in Milan, at the Milan Design Fair, was done for Italian furniture producer Cassina. And so they came to us again with their starting point was how is furniture changing because of the way we live in a different way today. Most of the things we do today in our daily life, the way we meet friends, read the newspapers, navigate the city and so on, are radically different than 10 or 15 years ago. In particular, you go home and 10, 15 years ago, you might have sat on a sofa with a newspaper open in front of you, and now you probably have an iPad. And you might be looking at the newspaper or doing email or posting on Facebook. So the question was, how could we design new objects that could respond to this? And one of the ideas, we developed 6 or 7 concepts, you find them online, but one of the ideas was the following, that we were working on different objects, and Philip Stark was working on a new sofa that you see here. So I want to say, well, what if we actually can create something that could be a standard basic coffee table, but also when you open it, it can become something that helps you to read on your iPad and look at the newspaper there and so on, or it can become something else in a flexible way. Well, the idea was okay, but the question is, how do you do that? How can you have a material that allows you to do that? And again, some of the changes in production that we've seen over the past few years allow us to do something we couldn't do before. If you look at this is a small hinge. And if you imagine to put together many hinges like this, but where every hinge is slightly different from the other, so all of them are produced in a digital way, so you design them and you've got thousands of hinges, but each of them is slightly different. Then what you can create, if the geometry is right, you can create a system that allows you to create different configurations that are stable. So again, you can have something that is stable, that's closed or open in one configuration or another. Well, this was the initial idea. We did a first mock-up, which is what you see here, and that is closed, and then we tried to open it, so that again was fabricated very fast. It's what a lot of, I think all of us here are familiar with, which is just simply laser cut or 3D print a lot of these objects. All of them are slightly different, and then the difference is that a few years ago you had to do every piece the same, otherwise it would be incredibly expensive. Now you can actually do everything different, and it's the same price. It's a bit like the old books. You had to do the same thing all over again. With a printer, with a digital printer, you can do 100 books all the same or 100 books all different, it's going to be the same cost. And then, we had to develop a bit the prototype, test the other things that didn't go in the right direction, and then the final one with all these elements made of wood and aluminum. And here you have it when it's the second prototype. Here's the machine, the laser cutter, cutting them very, very fast, just a few seconds per element, and then you combine all the elements together, you connect them, and then you get the final product that you see here when it's closed or when it's open in one way or open in the other one. Here's a quick video. And the same thing that you can apply at this scale, you can also apply to broader scale. In this project is a project for the city of Zaragoza in Spain, and Zaragoza had the World Expo just before Shanghai. So when they won the World Expo, the theme of the expo was water, like in Milan in 2015 would be food, and there it was water. So the mayor came to us and said, well, water has been a beautiful ingredient of architecture and planning for thousands and thousands of years, especially in Southern Europe, in Spain, and so on. How could we use it today in a different way? And one of the ideas that came up was, imagine you have a pipe, as you see here, and on this pipe you got many tabs, controlled by a computer that open and close it very, very fast. So you can create like a water wall, and on this water wall you can show images or text, or patterns, or this water wall can become like a living material. Again, you approach the water wall, it opens up to let you through. Well, this was the initial idea. We presented it to the mayor liked it, so we got the commission to design the building at the entrance of the expo. The whole building is made of water. There's no doors or windows, but when you approach it, it opens up to let you in. And when you're inside, all of the walls expand and shrink based on where people are. The roof is also covered with a thin layer of water. And then if you got too much wind, you can lower the roof to minimize splashing. Or at the end of the day, you can close the building and the whole architecture disappears. Hopefully without anybody underneath. We got sensors for that as well. So here you can see the building before the opening. This person actually was stopping by. You see he has a trolley. He was going to the station and stopped there to say, what the hell is happening here in this building? Here it was digital projections on the top of the water, so the physical pixels made of water and then pixels made of light. Here it was myself trying not to get wet in testing all the sensors that detect people when they approach the building and then stop the water, so open the door if you want into the building when you want to get in. And I should tell you now what happened one night when all of the sensors stopped working. All of the sensors are connected to a computer and the computer crashed, so they stopped working. And that night we were terrified because we didn't know what would happen. That night, the building would keep on doing its own crazy things, and cuts and holes and text and writing, but without responding to people anymore. But actually that night was one of the most fun nights ever. That night, thousands and thousands of kids from all of Zaragoza came to the building to play a new game. Not anymore a building that opens up when you approach it, but a building that you need to engage like this. And that was important for us because as architects, as engineers, we always think that we know how people will use the things we design. But then reality, and especially human reality, is always a big surprise. Well, what you saw here was actually trying to play with pixels made of water. We are still working on a project that actually tried to use pixels made of light. Imagine the same concept but with little points of light, something like this. So, well, what you saw here is the concept. Some of it was real footage, but a lot of the rest was actually synthetically produced. What you see here is actually some of the real flyers flying. Look pretty much like the others. Then you turn on the light. They look terrible at the moment, like this. They look like dead mosquitoes onto the floor. And now we're solving some technical problems. We've been having some delays on this project, but we want to actually create this kind of living, moving cloud that you can control. Now, this was just a quick summary or a quick view, or putting on the table some of the experiments we're trying to do, both in sensing, in collecting information, then using this information to respond, to change the city, the buildings, the places we live in. But I wanted to share with you one project in more detail, because I think in how the project was done, because I think that here is actually one of the main lessons about adaptation that you've been looking at throughout the series this year. And it is about adaptation in the sense of how much the role of the architect is changing and how different it could be tomorrow. Now, and before getting to that, I just want to share with you in a very plain way the project, what it was and how we did it. So the project started in the city of Copenhagen. The mayor came to us with a very precise question: how can all of this technology help us with traffic? And we decided, we went to Copenhagen with a bunch of students and researchers from MIT, and you could imagine the faces of these people, accustomed to the American way of moving and in the city, going to Copenhagen when actually movement and traffic means mostly what you see here. Copenhagen is a city where between 30 and 50% of all trips every day happen by bicycle. So we started working with bicycles and connected digital technologies, and we came up with this idea.
Welcome to the Copenhagen Wheel. The wheel that turns your ordinary bike into a smart electric hybrid. Quickly and easily, with no additional batteries or wires. The Copenhagen Wheel allows you to capture the energy dissipated while braking and cycling, and save it when you need a bit of a boost. Controlled through your smartphone, the Copenhagen Wheel becomes a natural extension of your everyday life. The Copenhagen Wheel is your personal trainer, sensing your effort level and providing you with real-time feedback about your fitness and exercise goals. The Copenhagen Wheel also enhances your experience with the city. It connects you with things the cyclist wants to know: upcoming traffic congestion, road conditions, and pollution levels. Choose to keep your data, or share it with your friends and other cyclists through social networks like Facebook. glide program for good for the environment. Elegant, responsive, smart. A new mode of transport for a rapidly changing world. So turn on your mind and turn on the city, the Copenhagen wheel.
So this was the idea, and let me tell you a little bit how we developed and how we got to that. So we started with a number of different ideas for the city, following the visit of the mayor with a workshop. We sometimes do this in a very open way with students. This was for a semester, students from MIT and from Harvard working together on the project. Out of the different ideas, one idea was actually this kind of funny looking wheel. A wheel that in the initial concept could collect energy, but really there was nothing technical there. It was just a concept, an idea, but nothing real, that could actually allow you to do this. And then, the student workshop ends, and at that point, when you got an idea, you don't know if it works, if it doesn't work. The best thing is let's try to make a prototype. So here is the first sketch from the time, the first prototype, the batteries, the motor, combining all of them together. The first wheel, it didn't look too good, but that was actually working. That's on the first bicycle. This was with the mayor in Copenhagen in the main square. So she liked it. So we said, okay, then let's actually do the real ones. So we went back to the drawing board, and that's really something that we're all familiar with in design. That you do something, you test it, you do a prototype, and then you go back and you try to make it better. So first we had to clarify to ourselves what we wanted to do. So in this wheel, we wanted something that could be easily retrofitted to any bicycle, have regenerative braking, so when you brake, you collect your energy, intelligent locking, so that the bike will open up, will unlock if it is you, but it will not unlock if it is somebody else. And if somebody steals it, you will still be able to find it, maybe after the burglar have recharged your battery. And then sensors in order to monitor air quality, distance, and so on, and also to make the bike almost like your fitness, your personal trainer, measure your fitness and give you back that information. Well, in order to do this, we had to change the design significantly. Here you see the second version of the motor, working together with people from many disciplines, from design, but from engineering, from mechanical engineering, and from many different disciplines, choosing the motor, then designing all the different pieces inside. So, the sensors and the sliders here in order to control the torque, in order that when you apply more torque to the wheel, then it knows the torque you're applying, and it becomes like seamlessly supplementing your torque. It multiplies it by 1 or 1.5 or whatever you decide. And then all the different pieces together. And, well, this was about the wheel in the center, the hub, but then also the casing, the spoking was important. We started with something like this. That was pretty ugly, as you can see. Then somebody has an idea like this one. It looked better, but didn't work. And you can see that this doesn't work because you cannot transmit the torque from the center of the hub to the rim on the outside. It doesn't do it well. It's not triangulated enough. And then, we came up with this idea that we thought was interesting. Here you have some spokes that just start from the rim and then simply touch the wheel and then go back without being connected to the wheel. And that, they're in tension, like in a bicycle wheel, and that connect the two components together. And we thought it was interesting, but some people thought it would work, some people thought it wouldn't work. Again, if in doubt, let's try it out. So this was the first little model made of simply laser cut elements, and then the second one done with a 3D printer. So, as you can very easily send it to a printer and you get the whole shape. In this case, it's made of resin, but you can also get it made of metal, in 3D printer metal. Then adding the spokes, you see the mounting of them. He was very skeptical, as you can tell. But actually, this is how it ended up working. So the wheel and the spoking system. And then, then there was all of the other part, the controlling from the phone. And that's where people from interaction design and, with more looking at human interaction with technology came into play, and graphic designers in order to design the interface and do all these different components we were mentioning before about green miles and navigation and so on. And then mounting that on the bike. And then also the sensing component. Here is where environmental engineers, students and researchers came into play. People today use bikes for sensing. These are real projects you find online. Well, I want to do something different, so something quite small that actually inside the wheel could help you to measure air quality. it becomes interesting because, the way you measure air quality today in cities is just with a few stations. I guess in Geneva there's probably 5 or 10. And those stations tell you very little about the exposure that each of us has in the streets. So if you can get measures of exposure as people move through the city, you get a much better fine-grained knowledge that can help you understand, where the problems are, how you can fix them, and also where you might want to move. What you see here is actually just a few bicycles, just a very limited number of bicycles moving in Copenhagen, and how much information you can collect from the city. And after just a few hours, you got almost like a real-time map of air quality in the city of Copenhagen. And you see every bike moving, and then you can overlap all of these maps and see what is going on. Much more fine-grained than what you can do today in cities. So, these were the main components, and then we had to present it in Copenhagen, so we had to build some prototypes. Here we had promised to build a number of them to test in Copenhagen. You see the different pieces being assembled, programming them, adding all of the microcontrollers inside, mounting them, and then shipping them to Copenhagen. We see it here. And here you see actually the presentation with the mayor. Here's the mayor of Copenhagen. Here is actually the first test that was done by the mayor of Copenhagen and the mayor of Toronto of the wheel. And so this was actually the first prototype. Now there's a company in Boston. There's a garage, the standard startup garage that are started from many ideas in Silicon Valley or in Boston from MIT. And it's actually working in order to release it as a commercial prototype next year. But what I wanted to share with you all of this to conclude with you and see with you some of the key points about the design process today. We used to think that knowledge was something like this, that everything could fit into the right spot. Actually, that, like in the time of St. Thomas, when he wrote the Summa, he thought that, we could actually classify every single piece of human knowledge. Now, if today we had to think about a possible map of knowledge, that might look more similar to this. This was a map that was on the cover of Nature magazine, and actually built using 800,000 papers, published and linked with each other, where every paper is referencing other papers. And what you see beautiful links appearing between brain research and computer science and math and social sciences, almost like something where everything is connected with everything else. So where the distinction between disciplines, actually those boundaries are breaking down. And also Nature looked at the most important papers in the past and today. Most important papers in the past used to be papers by one author from one discipline. There was still the idea that you could be like Newton, staying in Cambridge, UK, and then you had an apple fall on your head, and then you thought about gravitation, and then you had a great idea, and that paper would become an important paper, a paper that many people would cite. So important because of that. It's almost like on Facebook, the likes. That's the idea of the impact factor between papers, that many people would then like it and cite. Well, today the most important papers are usually done by many people from many different disciplines. And we think that something similar is now happening also in design. We used to have this idea of design. This is the idea that Corbusier had when designing his proposal for Paris. And his proposal was quite simple, was actually demolish all of Paris, just leave Notre Dame and a few other little things as memories of the past, and replace everything with these cruciform towers. And when you see this, when you see the hand, that is the hand de Le Corbusier, the Pavillon de l'Esprit Nouveau in Paris, presenting that on a crisp fall day, probably a bit like, a day like today, but that was 90, almost 100 years ago, over 90 years ago, then, you see his hand, that's the hand of the architect, but almost like the hand of God, presenting his design in a top-down way to people. And people used to say that we couldn't design collaboratively. There's even a saying in English that says, that the camel is a horse designed by a committee. Well, we think that actually all of that is changing. That today actually we can and we have to design in a much more collaborative way. As architecture is adapting, is changing, is looking at new boundaries, is crossing new boundaries, is really looking at this interface between us and the environment. In this interface, because of new technologies, is shifting and changing very rapidly. Then architecture itself has to be open to new disciplines and work in a much more collaborative way. And the only way we can actually solve some of today's and tomorrow's big challenges, the big challenges of cities, the big challenges of climate change and CO2 emissions, is probably only if we come together in a different way and try to look at them by sharing our different knowledge. Well, this is something you could call open source architecture in a certain sense. It's a kind of more collaborative way of designing. And Domus magazine had an issue on open source architecture a little over a year ago. And they asked me if I would write the introduction to the issue, the editorial for that issue. And I said, sure, I can do it, but if you're going to do something about open source architecture, about collaboration in design and so on, let's do also the editorial in a collaborative way. So we started working on it together on Wikipedia with people like Paolo Antonelli or Nicolas Negroponte, Hans-Ulrich Obrist, and many, many others. And then this piece kept on evolving and became actually what was printed in the magazine, but also what you find today on Wikipedia that keeps on evolving on its own. However, there was still a problem. The problem is that Domus, when they publish an editorial, they want usually to have a picture of the person who wrote the editorial. And so we said, which picture, which portrait should we give? And so, we took Photoshop and actually we added all the portrait of all of us, one on the top of the other, like this. And this is the picture I wanted to finish with. I wanted to finish with this as a kind of a wish. As a wish that tomorrow's architect will be a bit less like Corbusier with his hand from the top down, planning a city for millions of people without even engaging them or involving them, but a bit more like this, like an architect that it's in all of us. Thank you.